Hey there, ninth graders. Today's discussion answers video is going to walk you through the answers for your discussion on metals. So let's just jump right into it here. Number one said identify and define at least three major physical properties of metals. So there are a lot of properties of metals that you could have discussed or identified here. Basically, metals are going to be hard, they're going to be shiny typically, they're going to be what we call malleable and ductile. They're good conductors of heat and electricity. Those are some of the major physical properties of metals. Number two describes some real life uses for metals. This is really a wide open question. Metals can be used for a lot of different things, everything from construction, buildings, engineering type purposes, all the way down to, tiny little components in, electronic devices and things like that. So there's a wide variety of uses for metals, and really you can't really go wrong with any of your examples. I'm sure would be fine. So number three, where are the metals found on the periodic table in general? If we look at the periodic table here real quickly, I'm just going to actually pull this up right now because I forgot to pull it up before I started. If we look at the periodic table and we highlight the metals here, so right now I'm hovering over the metals. So these are all metals. All the ones that are in color here are all metals right now. So you can see that most of the periodic table is metals. Really, it's just the right side over here, which is your non-metals, the green and the purple ones. Those would be the ones that are not metals. And then you have your group of metalloids here as well in the middle. And so those would be not considered metals, but you can see that most of the periodic table is made up of metals. So that's where we would find the metals on the periodic table. All right, number four, explain metallic bonding. So I'm going to go to our cinch text here for a few of these questions. So this image here is attempting to kind of show you what metallic bonding looks like. And if you read the caption down here, it says in metallic bonding, the electrons in the shared electron C are not attached to any one metal ion. This allows the electrons to move. So if we look here, what they're trying to show you with these electron clouds here is that the electrons that are anywhere in this area, which they call the electron C, those electrons are kind of free to move around and move from atom to atom. So these are each, atoms of sodium, or in this case, they're ions of sodium. And the electrons in between them here are kind of free to move around. And so that's kind of how metallic bonding works, is that there's this sea of shared electrons between each of these atoms, and that essentially is what bonds them together. And so this is showing you how all these sodium atoms are bonded together by way of the fact that their electrons that they have are being shared between these different atoms. So that's what causes the bond to kind of hold them together. Okay. Number five, what is the relationship between metallic bonding and the conductivity and ductility of metals? So if we think about this for a moment, conductivity in terms of electricity means essentially that electrons are able to flow easily or move easily through a substance. So if electricity flows easily through a substance, that means that electrons are able to move. And so what we just talked about with metallic bonding is that these electrons in here are free to kind of move around, right? It's a sea of electrons. They're kind of floating in and around these sodium ions. So why can metals conduct electricity well? Well, because these electrons are free to flow, right? In a lot of other substances, the electrons are more fixed in a location, and so they can't really flow around as well. But in this particular instance, when you have metals with electrons that are kind of moving around in here, that makes it much easier for electricity to flow through a particular substance. And in this case, it's a metal. Okay. All right. Number six, what is group one in the periodic table called, and what are they known for and why? So group one are called the alkali metals. And what they're known for is their reactivity with water. So if we go to the periodic table here, this is group 1 right here. It does not include hydrogen, technically. It's these metals: lithium, sodium, potassium, rubidium, cesium, and francium. So they're known for their reactivity with water. And you're going to watch a video actually later today after you're done with this discussion on the reactions of these things with water. And you'll kind of see why they're known for that, because they cause somewhat explosive reactions when you add water to them. So those are the alkali metals, and they're known for their reactions with water. All right, well, let's go ahead and go to slide 2 here. Number 7 said, what is group 2 on the periodic table called, and where might you find these elements in use? So group 2 is going to be the alkaline earth metals. And I'm going to go to Cinch here to kind of show you where the alkaline earth metals are and what they're used for. So this is the section on alkaline earth metals. You can see that one of their major uses is fireworks, actually. And they're in group 2 on the periodic table. So these are your alkaline earth metals right there. And so you have things like magnesium, which are also used for like making cars and planes and spacecrafts and those kind of things. Even baseball and softball bats have some magnesium in them typically. Calcium is used, or I should say compounds of calcium are used for quite a few different things, or can be found in nature pretty readily in things like minerals, limestone, those kind of things. And then you have other uses like X-ray radiation and things like that. So alkaline earth metals have a lot of different uses. But their most prominent one is probably this, the firework usage, because they burn at different temperatures, which causes them to produce different colors. And so that's why they use them for fireworks. Number 8, what do we call groups 3 through 12? Those are called the transition metals. You might also see them called the transition elements. There's not a difference between those two terms. Those are the same thing. So don't worry about the difference. They both are acceptable answers. Number 9, what elements are included in the iron triad and what are they used for? So back to your Cinch book here, the iron triad is going to be these 3 elements right here. It's going to be iron, cobalt, and nickel. And these things are used in a variety of different ways, but we typically see them with like coins and metals and things like this. Copper, silver, gold, these are used for things. The iron triad itself is going to be used more for components of steel. Iron is a big component of steel, but they also mix it with nickel and cobalt and things like that to give it different properties and characteristics and things like that. So these are the most common magnetic elements are used in steel and other metal mixtures. So lots of different uses for these, but the most common usage is probably the ability to create what we call steel out of these particular elements. Okay. Let's see. Number 10, what properties make the coinage metals useful for coins and jewelry? So things like gold and silver, the things that make them useful for coins and jewelry would be their luster. So they're typically really shiny. They are also fairly malleable, which means they can be molded into different shapes, which obviously is beneficial when you're trying to make coins or make jewelry. You want to be able to mold them and shape them into different shapes. So those are some of the properties that make them appropriate for coinage and for jewelry. Number 11, why are the intertransition elements below the periodic table, and what are the names of the 2 rows of intertransition elements? So let's take a look at the periodic table here. So these 2 rows down here are what I'm talking about here. So the names of these rows, row 6 here, these are the lanthanides, and they're named after the first element in that row. So lanthanides is the top row, and then you have your actinides, which is the bottom row. And really the only reason these are removed or put below the periodic table is to simply save space. That's really the only reason. It's a very simple reason. So if these were to be up in here, then the periodic table would be much, much wider, and it just wouldn't fit as well. So really the only reason these are taken out is to save some space. and make it more clean looking. So pretty simple answer on that one. All right. So I think that wraps up our discussion for today. If you have questions, let me know. Thanks.